Rolls-Royce Power Systems has achieved a major technological milestone that could reshape the future of marine propulsion. At its research facility in Friedrichshafen, Germany, the company successfully tested the world's first high-speed marine engine powered purely by methanol. Unlike experimental systems that rely on hybrid or dual-fuel approaches, this prototype runs entirely on methanol, an achievement that could redefine how ships, ferries, and offshore vessels navigate in a cleaner and more sustainable way. This engine was developed under the German government-funded Miochmer project with partners Woodward L'Orange and WTZ Roblau. The test is a critical leap because methanol, unlike diesel, does not auto-ignite. Engineers redesigned the fuel injection system, turbocharger, combustion strategy, and engine control software. The result is a fully functional high-speed engine that operates smoothly, delivering stable ignition, strong power, and efficient fuel use with far lower emissions than conventional marine diesels. Methanol has long been viewed as a promising clean fuel for ships. It can be produced using renewable energy via power-to-X pathways that combine captured CO2 and green hydrogen. When sourced this way, it is nearly carbon neutral. It remains liquid at ambient temperatures, making it easier to store and handle than hydrogen or ammonia. That practicality allows operators to decarbonize without rebuilding entire vessels or port infrastructure. Rolls-Royce's engine is designed to exploit exactly that advantage. This technology stands out because it is not a retrofit. It is a clean slate design for high-speed vessels that demand fast acceleration and reliability. Most alternatives today are dual-fuel or partial conversions. By committing to single-fuel methanol, Rolls-Royce targets ferries, luxury yachts, and offshore support ships that need power density and rapid response. Unlike LNG, which requires cryogenic storage, or hydrogen, which faces density and infrastructure hurdles, methanol offers liquid fuel convenience while meeting tightening emission rules. The Miochmer team describes this as a turning point for clean propulsion. Shipping contributes a meaningful share of global carbon emissions. Methanol engines promise dramatic reductions, and with green methanol, the potential for near-zero life cycle CO2. The Rolls-Royce result shows that this shift does not have to trade away speed or uptime, a crucial factor for commercial operators. The moment couldn't be more critical. The International Maritime Organization is tightening global emission rules, pushing the marine industry toward rapid decarbonization. Engine makers are racing to provide credible options. Companies like MAN Energy Solutions and Wärtsilä are advancing dual-fuel methanol engines. Rolls-Royce's pure methanol approach aims higher, eliminating diesel backup and focusing on clean combustion with next-generation electronic controls that optimize every cycle. Challenges remain. Methanol's lower energy density means more volume for the same range. Materials and injectors must handle corrosion and lubrication differences. The biggest external hurdle is scaling green methanol supply. Much of today's methanol is fossil-derived, but new plants in Europe, the United States, and Asia are ramping renewable production. As capacity grows and costs fall, methanol's case strengthens for commercial fleets. Historically, this marks a new phase for marine innovation at Rolls-Royce. Known for precision engineering and aerospace propulsion, the company has been expanding into sustainable power systems. This test reflects a long push toward low-carbon solutions and aligns with a net-zero roadmap. It shows how a legacy industrial player can transition from traditional engineering to climate-conscious technology without losing performance leadership. If the technology scales, the implications are powerful. High-speed ferries could connect coastal cities with minimal carbon. Luxury yachts could cruise quietly on clean fuel. Offshore supply ships could serve wind farms and platforms with far lower emissions. A methanol engine platform like this could anchor a new era of green shipping, replacing heavy fuels with a practical, efficient, liquid alternative. Rolls-Royce's methanol engine shows that innovation can deliver real environmental gains without sacrificing performance or reliability. If this future excites you, power it with your action. Like this video, subscribe to Dezhn, and drop a comment with your take on methanol at sea.